Hello everyone, welcome to Maths Essentials Part 1. In this session we're going to be having a look at 3 key considerations for the successful teaching of mathematics. To help illustrate these, I'll be showing you an activity that you can probably use in your classroom. We'll be looking at how this activity follows or can be at least made to reflect these 3 considerations, because really they are things to keep in mind that will affect your pedagogy. Alright, let's jump straight into the activity first and see what we have to work with. Okay, so our bingo sheet, and we roll a couple of dice. Right, 3 and 7, so we have to work out 3 times 7. Now obviously the children don't know how to do that yet, so what we're going to do is give them a scaffold in the form of a 10 by 10 array. Now we have 3 and 7, so we don't really need to try and labour the theory behind it too much at this point. We do is show them the mechanics. So they need to have a count of 7 up here, and they need to have a count of 3 down here. So, as you can see, 3 by 7 gives an array, and the children then just need to work out how many dots there are on that array. Now, they can count by ones, and that's fine initially, but eventually we want them to start thinking about unitising. And one good metaphor for unitising was this idea of yarata. So yarata being a string that fish might be strung along, and it allows them to be carried, tied around the waist or whatever. So yarata is a line with fish strung on it, and that seemed to be something that resonated with students when it was tried by the UNL teachers in Allamore a year or so ago. So we can actually physically show these yarata if we want to. We can draw lines down like this, just to help the metaphor. And okay, so students can then see that we have 1, 2, 3, 4, 5, 6, 7 yarata, each yarata consisting of 3 dots, 3 fish, whatever. Okay. Once the students determined how many spots there are, they then locate that number on their bingo sheet. In this case, there are 21 dots, and so a counter is placed on the 21 on the bingo sheet. Students continue rolling the dice and working out how many yarata, how many dots there are altogether, and filling in the bingo sheet. It can make it a quick game, could just be 3 in a row. A longer game could be the entire bingo sheet. It's a matter of the student's interest and what your intentions are. So this sheet here only works when you have a 10-sided dice and one that only has numbers up to 3 on it. So obviously this is a doctored dice, or doctored die. I just got it from here and used a permanent marker. We have a few of these still left in the school, these cans of blank dice, and I can order some more. If we run out of dice, or you haven't got them or can't find them, that's okay. We also have this, which can just be printed out. Now this is our spinner, and to use these spinners, it's nothing exciting. You don't need to cut them out or use toothpicks or anything like that. All you need to do is get a pencil and locate it in the middle of the spinner, and then flick the paper clip and you'll get a fairly random spin, and that works on the spinner. Alright, so we have a worksheet for 1, 2 and 3. We also have one that works with 2, 3 and 4, 4, 5 and 6, and then we skip to 7, 8 and 9. So we can make sure the children practice their 1, 2, 3 number facts at the same time as building the concept that they're really talking about numbers of groups of numbers, or numbers of objects that are comprised of more than one object. In this first case, we were looking at things we were calling yarata, where the yarata was consisting of 3 objects. So what are the key considerations I mentioned at the start, and how does this activity reflect them? Consideration 1, from the concrete to the abstract. First learning experiences with a new idea should be hands-on. That is, they should employ concrete materials that can be physically manipulated by the students. In this case, it's not quite concrete. We're looking at arrays and there is some manipulation going on, but those arrays are really representations of dots on paper. It probably wouldn't hurt to introduce some actual physical manipulatives, such as counters or blocks, to begin this activity. Some linguists believe that all abstract thought is metaphorical in nature, that we can't actually understand any form of abstraction unless we have some sort of link from that abstraction to a lived reality. Scaffolding, the use of concrete materials, is vital for building understanding. It helps provide a concrete anchor for the abstract concepts that we're teaching. This brings us to our next key consideration. Understanding is the primary goal of teaching mathematics. Too often, students get the message that mathematics is just about getting the right answer. Really, it should be about students being able to understand what numbers are and how they work so that they can confidently manipulate them in order to solve problems. In other words, mathematics should be all about trying to instill a number sense. Memorising number facts is of little use if understanding is not being established. Memorising timetables, for example, is fairly pointless in itself unless the student is also acquiring multiplicative thinking and number sense about multiply. Without this, a student may know that 7 times 3 equals 21, but will have no idea of what to do with this knowledge or when to apply it, other than maybe when they see the appropriate equation written on a test. This activity is designed to help students to see the underlying ideas behind multiplication. One last point about understanding, and this may seem obvious, but the language supporting the discourse must be comprehensible to the student. The words must be familiar, and they must call to a lived reality that the students can relate to. It is particularly difficult to achieve in a situation where we're teaching across language and across culture. It is important, therefore, that Yolngu staff are given the time to come up with some Yolngu interpretations of these key ideas in maths, and that they're given the time in class to help establish those meanings with the students. The final consideration that we'll examine today is something called automaticity. While meaning is still the primary understanding, automaticity is still an important secondary goal. When we say automaticity, we're talking about instant recall of number facts. While the ability to instantly recall number facts alone is of fairly limited use, the ability to instantly recall number facts when it's backed up by a deep understanding of how those facts came about is very, very useful. Consider a literacy example. When students are first learning to read, they may have to decode laboriously each word within a sentence if they don't recognise them instantly. By the time they get to the end of the sentence, they have no idea of what the sentence is actually saying, of what it's trying to communicate, because their brain has been completely engaged with the task of decoding each word. Mathematics is a little bit similar. When students get into higher levels of mathematics, the problems involved require many small calculations, but they also require the mind to be considering the big picture. In order to become fully numerate, a student needs to be able to have both understanding and instant recall. This is why scaffolds, such as concrete materials, while they're vital for building understanding, an exit strategy is also needed. In other words, a gradual de-scaffolding is vital if students are to become functionally numerate. The inbuilt structure of this game and the random elements means that students will be continually rolling dice in an effort to find the desired numbers. In this process, they'll continue to roll the same pairs a number of times, and in doing so will come to understand that they recognise those pairs and already know the answer without having to work it out. A key feature of this activity is that de-scaffolding occurs naturally as students come to recognise more and more the pairs of dice that they're rolling. It also helps that the times table families, if you like, are limited to 3 in each case. That's why we have 1, 2 and 3 in the first game, and it focuses entirely on these 3 sets of times facts. Now, go and choose an activity from Talking Number or some other source and explore it to see how it satisfies or can be made to satisfy these 3 considerations. Thank you for listening.